So, what's up everybody? This is again your resident chemist / teacher Mark, and today we will solve another problem involving gases. So, may I bring your attention to our problem here on the other screen? When a large flask is filled with argon gas, its mass increases by 3.2424 grams. When the same flask is again evacuated and then filled with a gas of unknown molar mass, the mass increases 8.102 grams. So the problem already gave you a hint. You use the molar mass of the argon to estimate the molar mass of the unknown gas, and then it also states what assumptions did you make in arriving your answer. Now, in the way I solve it, I gave first the letter B, since if you know the assumptions that you make, if you know what assumptions you're going to make, you will be able to get A, or the mass of the unknown gas. So I made an illustration out of the given. So as stated in our problem, we have an empty flask. We have an empty flask of unknown volume, and under the laboratory pressure and temperature P and T respectively, then we fill it with argon gas. And it was shown that after filling with argon gas, the mass of the flask increased by this value. Since the flask was initially empty and it increased by this value, that means this is the mass of the argon added or pumped into the flask. Okay, so then we take argon out, then we replace it with an unknown gas at the same pressure laboratory conditions, and it has shown that the mass increase changed from 3.224 to 8.102 grams. This means that this mass increase is due to the mass of the added unknown gas. So what we were trying to find here is the molar mass of the unknown gas X. Switchboard. So let's perform the ideal gas equation. Wait lang guys, sorry. Naglag. So let's do the ideal gas equation on this two substances, on both the argon gas and the unknown gas, okay? So here, PV, nRT, so on and so forth, and we know that molar mass is equal to the mass of the substance divided by its number of moles. Remember that the definition of the molar mass is the mass of a pure substance, may it be an element or a compound, present in 1 mole of it. Okay? So after all, since its unit is grams per mole, that means the molar mass is equal to the mass divided by its number of moles. So we do that both in argon and both in the unknown gas, namely X. Okay? So we manipulate this equation to express it in terms of the number of moles. So that here we have shown that mole argon is equal to this expression. The same goes with this one. Okay? We substitute this expression to our ideal gas equation, which will result to change board. Wait. So our equation changes into we do it once more again, sorry, into this one. So the same thing we do on for the ideal gas equation of gas X. Okay, like that, right? Now, since these expressions do not remain constant all throughout the experiment in the given, we transfer this to one side of the equation. So this will result into the rearrangement of the equation. Like this. The same goes with here. Mamuna siya. Since these are constant throughout the experiment, that means these two rather are equal with each other. Therefore, the number of moles of the argon added into the flask is equals to also the number of moles of the gas X added into the flask. Okay? Again, change board kita liwat. So, from this expression, we can substitute them to each other, which will result into this one here. Now, since this is known and we don't know this, we rearrange the equation such that this is the only one left on one side. So therefore, your final equation or your working equation will be, so transpose this to here, this one here, this one here. Mamuna siya, okay? So we plug in our values. So mass of X is equals to, a molar mass of X is equals to 8.102 grams multiplied by the molar mass of argon. What is the molar mass of argon? Okay, guys, let me check. Sorry guys, I just have to do this since I'm a fan of the Amazing World Gumball. Commercial break! Okay, so finally, nakuha ko na molar mass ka argon. It's 39.904. Sorry, you get it 39.904, 39.948 grams per mole divided by the molar mass of your argon, not the molar mass, the mass of the argon in the given, which is 3.224 grams. Okay, so equal to, plug in sa calculator, 8.102 times 39.948 divided by 3.224 equals to 100.39 grams per mole. So that is our final answer. Okay. What else do I want to say? So before I end this vlog, above vlog. Wait lang. Okay. So before I end this vlog, I would just like to tell you how to solve problems, not only what I have presented in gases, but on other problem solving, not only in chemistry, but on other disciplines involving mathematics, such as physics and others. So what you need here is you cannot get it at first. There are some problems you cannot get at first try. What you have to do, it's matter of practice, and more practice. Although, I don't know, do ka panos sa ginang saying, practice makes perfect, but nobody's perfect, so why practice? That's only for quitters, joke lang. I mean, that's really pure bull crap. Yes, it is true. Nobody's perfect, so but practice does not make perfect, but practice borns mastery. Okay, so if ma-practice ka mo nga ma-practice, although hindi nyo ma-perfect, at least you'll become more experienced on solving problems that like this, or like the one that I have shown in my videos here. So I'll end it here for now. Thank you everyone for watching. So don't forget to subscribe, because I'll be posting more videos regarding our topics in chemistry. And I don't know, I might post videos regarding whatnot. So that's it, mga kabeaker. I don't know if I'm gonna use that catchphrase. So yeah, see you.